Alright, today we will cover special segments of triangles. So these are, in triangles, there are certain segments we can draw inside them, and there will be special properties that we can see. So here we go. There's about 5 special segments that we're going to take a look at today. First up is a mid-segment. Mid-segment, x, y, z, y, and zx, x, y, z, y, zx, are all mid-segments of triangle ABC. So if you would notice, mid-segment means middle of the segment. A mid-segment, I'll write it up here, goes from midpoint to midpoint. So it connects to midpoints of two sides of a triangle. That means, because y is a midpoint, that means cy and yb are congruent, ax and xb are congruent, same over here, congruent, congruent, and congruent. The mid-segment length is half the length of the third side of the triangle to which it is not connected. That's a mouthful. So what that is saying is xy right here is half the side it's not touching, AC. And we'll see an example down here in a few seconds. So the mid-segment xy is also parallel to that side AC. So I'll just say the mid-segment is parallel to the side it is not touching. Much easier to say than the third side to which the triangle is not connected. Alright, so example of mid-segment right here. Length xy. Xy is right here. It's parallel to AC. Xy, AC parallel. That means if AC is 16, half of 16, 16 divided by 2 gets me 8. Next up is zy. Here's zy. Zy is parallel to AB right there. These are the parallel sides. If AB is 8, half of 8, not 8. If AB is 12, half of 12 is 6. Last one, zx over here. It's parallel to CB. CB is 20, so half of 20 is 10. Alright, in this diagram, AB is a mid-segment of the triangle. Because it's a mid-segment, these two sides are congruent. These two sides are congruent. So if LN, my bottom side, is 28, that means AB, the mid-segment, is half that 28, 14. Working backwards, if AB is 55, then LN, it's double 55, 110. Over here, if LA is 12, then AM, they're congruent, they're the same, it's also 12. And last up, if MN, my whole right side is 20, is 40, whole right side is 40, then BN would be half of that because that's a midpoint. Midpoint goes through the middle. Midpoint is 20. So there you have mid-segment. The key thing here is mid-segment goes from midpoint to midpoint. And we can determine that they're midpoint because these two sides are congruent and these two sides are congruent. Next up, we have altitude of a triangle. The altitude is our fancy word for height. The altitude is the height of a triangle. Altitude is drawn from a vertex, meaning one of the corners, and is perpendicular to the opposite side. So when I look at the picture, when I look for altitude, I'm looking for, it goes from vertex to a right angle. There's three different ways to draw an altitude. It depends whether we have a right triangle, an obtuse triangle, or an acute triangle. And we'll see it down here. Over here we have a right triangle. So altitude goes from vertex straight down to the other side where it forms a right angle. That's one way to draw altitude. Another example, if I turn my paper this way and pick B as my vertex, I need to make a right angle over here. So that's kind of like 90 degrees. There's another example of an altitude. Over here, let's pick A. From my vertex, I need to form a right angle perpendicular to the opposite side. So there's my altitude. Or if I pick, this time let's pick C as my example. Here's C, my vertex. The altitude needs to form a right angle. And what I would sometimes do to make it easy is if you use a ruler, and your rulers are going to have these tick marks for measurement. If your tick mark right here, let me zoom in there. That tick mark, if you put it exactly on top of one of those sides, that's going to be a right angle, because these rulers have 90-degree angles with a tick mark. There's your altitude. Okay. Alright, and this was for the acute triangle. Right here we have an obtuse triangle. Because it's obtuse, if I were to pick my altitude as A, going straight down will have me end up being outside that triangle. So if you're going to be outside the triangle, what we can do is extend that opposite side. So side B goes that way. So if I make my right angle from my vertex, there's my altitude. Alright. Or if I pick B as my vertex, and flip my paper around, I want to form a right angle with the opposite side. There's my right angle. The altitude can be in there. Vertex to right angle. Alright, example, angle ML is an altitude. Because ML is an altitude, that makes this a right angle and that a right angle. These two are right angles on the left and the right. So ELM, right angle, 90 degrees. LME, we're missing this side. So right now, I don't care about the left side of the triangle, let me cover it up. Looking at the right side of the triangle, I have a 90, a 60 to find my missing side. 180 minus, I know there's some scratcher here. 90 plus 60 gets me 150, so it's 180 minus 150. Tells me right here is 30 degrees. Looking at angle LMU, that's this top corner up here. Let me cover the other triangle. For that top corner, again, we need 40 plus 90. Gets me 130. That means between these two angles, I have 130 degrees. How much am I missing to complete my 180? So 180 minus 130 equals 50 degrees. So altitudes form right angles. They go from vertex to right angle. Next, we have the median of a triangle. Median of a triangle connects a vertex of a triangle to the midpoint of the opposite side. So let's write here, it goes from vertex to midpoint. Vertex corner, midpoint, we know this is a midpoint because BM and MC are congruent as indicated by these tick marks. Alright, let's go to the example. AM is a median, that means BM and MC are congruent. So if MC this side is 28, that means MB the other side is also 28, that's what congruent means. And my whole BC, 28 plus 28 gets me 56. Over here, they say MC is x plus 10 and MB is 3x. This time, they are congruent. Congruent means the same. It also means equal. So my equation is going to look like 3x equals, they're the same, x plus 10. Solving for x, we get x equals 5. So to find MC, we get 5 and plug it in here. 5 plus 10, which gives me 15. Again, get 5 and plug it in here. 3 times 5 gets me 15. If you do it correctly, these two numbers should be the same because M is a midpoint, meaning the left side and the right side have to be the same. So median, from vertex to midpoint. Next, we have perpendicular bisector. This is a word that we've seen before. Perpendicular means it forms a right angle, and bisector means the side is cut in half. So what I want to look for is my line passes through a midpoint, and it forms a right angle. Let's go down to my examples. Here's my line. It passes through the midpoint. We know x is a midpoint because BX and XC are congruent as shown by these tick marks. So it's a midpoint and we have a right angle, perpendicular bisector. Right, number 1, if BC is 16 units and MC is 37 degrees. BC 16, BX, it's a midpoint, it's halfway. 16 divided by 2 is 8. XC, CX, same thing. 16 divided by 2 is 8. Now, what is the measure of the angle formed at the intersection of line P and segment AC? Alright, the English can be confusing if you don't take some time to process it. So focus on these two parts, intersection of line P and AC. Here's P, that's the letter P. So we're looking at this part and AC. Here's AC. So we're looking at this part. So my intersection is right here. So to find that angle, here's 90, right there's 37. What's my missing angle to complete my 180? 90 plus 37 gets me 127. So 180 degrees minus 127 gets me 53 degrees. Alright, I'll jump down to my last example, the angle bisector. Angle bisector, again, it's not a new word. Bisector meaning we cut in half. Angle bisector of a triangle, cut each of the angles in half. Two equal parts. Alright, example. CAT, this whole angle is 86 degrees. So what is CAB, the left side? 86 divided by 2, that gets me 43 degrees. What's TAB, the right side? Again, 86 divided by 2 gets me 43 degrees. Because it's an angle bisector, the left side and the right side should be equal. Right, last up, CAB is 3x minus 3. So over here, it's 3x minus 3. TAB over here is x plus 8. So what's my equation? Again, because these two are congruent, angle bisector creates two congruent angles. They're congruent, they're the same, they are equal. So my equation should look like 3x minus 3 equals x plus 8. Congruent means they're equal to each other. Solving for x, minus x, minus x. That's me 2x minus 3 equals 8. Add 3 to both sides. That's me 2x equals 11. Let me move over here. 2x equals 11. Dividing both sides by 2, we get x equals 5.5. So there you have your 5 special segments in a triangle. We have the angle bisector, which cuts the angle into two congruent parts. We have the perpendicular bisector, which goes from midpoint, and it has a right angle. Midpoint, right angle. Then we had median. Vertex, one corner, to midpoint. That's the middle, because these two sides are congruent. That's a midpoint. Then altitude, which goes from vertex up here to right angle, or vertex to right angle, altitude. And we had the mid segment, which goes from midpoint to midpoint. We know these are midpoints because y is a midpoint because CY and YB is congruent. X is a midpoint because AX and XB is congruent. So there you have your five special segments.